In this session, we'll discuss about data security. Data confidentiality, data integrity, authentication are three important security properties by which one may achieve data security. Let us first discuss about these three important security properties. After that, we will use some cryptographic primitives, particularly symmetric key cryptographic primitives, by which one can achieve data security with the help of data confidentiality, integrity, and data authentication. First, data confidentiality. So, what is data confidentiality? Confidentiality means information is accessible to authorized entities only. In other words, unauthorized parties should not be able to learn anything about the information or data. There are several applications where you can find data confidentiality is one of the important requirements. For example, if you are storing data in third-party server, you want your data to be protected from others and you do not want your data be accessible by others. So those who are authorized, they will be able to access your data. Suppose you are sending one file to your friend over public channel. Then you want to make sure that other party than you and your friend, any other party should not be able to get any information about the file. Now, how we can achieve data confidentiality? There are many ways by which one can achieve data confidentiality. We will come to that. Now, next, data integrity. What is the data integrity? That data is not going to be altered. Data tampering should be stopped. And if data is tampered with, data is altered, then one will be able to detect that this data has been altered or tampered with. Now you will find many applications. For example, you are buying something in online e-commerce website, and for that you are sending credit card or debit card information. Now if somebody is altering your debit card, credit card information, then your bank, that card issuer, will reject your payment request. Now what you can see, that credit card information which was provided, if that has been altered by any other party or because of communication error, then credit card issuer bank will reject. Another example, suppose your mark sheet, transcript. The transcript provides that your courses, grades, marks, and so on. And that transcript is basically endorsed by your university. Now, if anyone is modifying, changing something on that transcript, then that transcript is considered as invalid because the integrity of that transcript is lost. How we can achieve integrity? I'll come to that. We can use different primitives by which one can achieve data integrity. Third one is authentication. Authentication is a process by which one can verify the legitimacy of an entity. One can verify identification of a party, or one can also verify the source of the data. Enormous applications you will find where authentication is one of the important requirements. For example, if you want to withdraw cash from automated teller machine, then you require to insert your ATM card and you need to provide PIN. Now, if your card and PIN both are found valid, if that card and PIN are being verified by your bank, then only you will be allowed to withdraw cash from your account. Similarly, your transcript has signature of your university authority, and if you modify the transcript, then that authenticity of your transcript is lost. So it will not be acceptable by other party. We will say that this signature is provided, but counter signature is not provided where you have, if suppose you have made some modification. So it will not be acceptable. Okay. Now how you can achieve authentication? Let us see some of the cryptographic primitives. We will basically consider in this session symmetric cryptographic primitives by which we will try to achieve data confidentiality, data integrity, and authentication. In symmetric cryptography, encryption, decryption is one of the important primitives. Then we have pseudorandom function, hash function, another important primitives, and using pseudorandom function and one secret key or symmetric key, there is another primitive which is known as message authentication code. Now using encryption and decryption, symmetric key encryption and decryption, let us try to achieve data confidentiality. So that there are broadly two kinds of symmetric key encryption algorithms. One is block cipher, another one is stream cipher. Now block cipher, at a time one block is going to be encrypted, whereas stream cipher at a time one byte or one bit is going to be encrypted. Now for these two kinds of ciphers, one important requirement is that both sender and receiver, they have to have knowledge of the common symmetric key. Let us assume that that common symmetric key is shared between sender and receiver, between encryptor and decryptor. After that, encryptor and decryptor, they can use either block cipher or stream cipher. If block cipher is used for data confidentiality, then there are many block ciphers, standard block ciphers which are being used in real world applications, namely Advanced Encryption Standard, or in short AES, or triple dash. It is a variant of data encryption standard, or there are many other symmetric key block ciphers. Stream cipher RC4 is widely used, reversed cipher 4, or one can use linear feedback shift register kind of stream cipher. Now using this block cipher or stream cipher, how data confidentiality can be achieved? Let us consider Alice and Bob. They are located at two different places. Alice wants to send some message in a confidential manner. So Alice will encrypt the message using a symmetric key, and that symmetric key is shared with Bob by some means. After encryption, Alice will send that encrypted message, which is cipher, over in secure channel or over public channel. After receiving that message cipher, Bob will decrypt, perform decryption operation using the same symmetric key, and after decryption Bob will get to know about the message. Now here you can see Alice and Bob, they can communicate each other in a confidential manner. And the cipher who is having cipher, any other party, will not be able to learn anything about the message. Now, if we consider a simple example, for example, say bitwise exclusive OR operation for encryption, then you have a message, string of bits, you have a key, again string of bits, and here assumption is that both message and key, they are of same length. Now you perform exclusive OR of message and key, then you will get the cipher, the same length of message and key. Now given this cipher, it is practically difficult to understand what is the meaning of the message. Now when we design any encryption algorithm like this bitwise exclusive or say advanced encryption standard or data encryption standard or RC4, one important requirement is the security of that cipher. Now, if you consider this bitwise exclusive or encryption, here you see that security is weak and security is not up to the mark. Why? Now here one potential threat is that vulnerability, that if a person is knowing both message and cipher, then he or she can calculate what is the key, because message and cipher JOR will basically give back key. Now if key is known, then everything is known. So that person can perform encryption, that person can perform decryption. So in short, this bitwise JOR encryption, where key is static, is not secure against known plaintext attack, chosen plaintext attack. So any modern cipher which is used in real world applications must be proven secure against known plaintext attack, chosen plaintext attack. Now next is how we can achieve data integrity. Simple way to achieve data integrity is you can use any pseudorandom function, in particular cryptographic hash function. What is that cryptographic hash function? It is a function that can take any arbitrary length of input and it outputs a fixed length of string. So you give any length of input, then you can get a fixed length of output. And that is why this kind of function is known as message digest function. So your input could be any length and output is a digest, a fixed length of string. Now this cryptographic hash function must satisfy two important properties. First one is that hash function must be pre-image resistance. What is that? It is one-wayness property. So given digest, no one will be able to tell anything about the input. So if you perform hash on a message M and the digest is 128 bit, then from that 128 bit digest, no one will be able to tell anything about the message. So that is pre-image resistance property or one-wayness property. Second property is collision resistance property. Now collision resistance properties, it is saying that you will not find any two messages M1 and M2 such that hash of M1 equals to hash of M2. So it is practically difficult or intractable problem, computationally intractable problem to find any two messages where they will give the same hash value or same digest value. Commonly used hash function for data integrity are SHA family, SHA1, where digest size is 160 bit, SHA256, where digest is 256 bit, SHA512 bit, digest is 512 bit, or one can also use MD5. Similarly, you will have other different kinds of cryptographically secure hash algorithm. Now, using hash algorithm, one can easily achieve data integrity. For example, you have your pen drive, so you can also compute digest of all files in your pen drive. So that the digest size of all file is suppose 128 bit. The next day when you are again using that pen drive, you can check whether any file has been altered or not. How? Again you compute hash of all files in your pen drive, then you will get a digest. Now you compare that previous digest and currently computed digest. If both match, then files have not been altered. If there is any difference that they are not matching, then any file, any data stored in that pen drive got changed. Okay, so you can easily check whether integrity of a file is lost or not. Another interesting primitive that can be designed with the help of pseudorandom function and using symmetric key, that is message authentication code. Now using message authentication code, one can achieve data authentication. Now suppose Alice has the symmetric key which is shared with Bob, and Alice wants to send one message and Bob has to ensure that that message has not been modified in transit. So message authentication should be provided to Bob. So Alice will do what? Alice will use the similar hash function or any pseudorandom function. Then it can compute message authentication code. So that function will take two inputs. One is message, another one is key. Then that code is computed. After that, Alice will send message along with the code. After receiving message and code, Bob will verify whether message was modified in transit or not. So Bob will again compute the message authentication code using the same algorithm, using same symmetric key. Then it will basically verify whether received MAC message authentication code and computed message authentication code. If they differ, then Bob will not accept that message, or Bob will say that message authentication is not provided. If they are matching, then both received MAC and computed MAC. If they match, then authenticity of the message is provided. Okay, so very efficient way to achieve message authentication. Now you will find different primitives. For example, one can use simple hash like SHA family or MD5. One can also use CBC MAC, that cipher block chaining mode of operation, and one can also go with HMAC, that is also known as keyed MAC. However, one thing one has to understand that when we are using any pseudorandom function or any say message authentication code, whether security is going to be achieved or not. For example, if you look at CBC MAC, so CBC MAC, that it works in a way that cipher block chaining. So it will continue that encryption operation till that message, last block of the message is there. After last block of message encryption, then MAC is going to be computed, and that MAC is a fixed length of string of bits. In this case, that key is one of the inputs, message and key. These are two inputs for this function. Now if key is prefixed, initially key was given, then first block message was taken as input, and after last block of message, MAC is provided. So in that case, one can forge this kind of message authentication code. How that can be forged? Now it will find two pair of messages, and there is a third message, and for that third message, that authentication code, message authentication code is going to be same. So in that case, the original message for which message authentication code was provided, then adversary will find another pair of message by which same authentication code is produced. So in that case, in place of original message, that third message is going to be replaced, and receiver will not be able to verify whether it was replaced or it was sent by the sender. Now, how one can avoid vulnerability in message authentication code? Simply, one has to avoid secret prefix method. If key is first, then message, so that will not provide security. Similarly, secret suffix, that message appended with key, so that has to be also avoided. In other words, we have to incorporate both secret prefix and secret suffix. For example, key, then message, then key, same key. In particular, in CBC MAC, so if someone is using one optional encryption where actual key and message length will be included to derive a new key, and that new key should be used for message authentication code. So a message of the length is going to be one of the important factors. If we include that, then CBC MAC will provide intended security. Otherwise, one can opt for HMAC. Now, design of HMAC is in such a way that you have secret prefix and secret suffix both. So here, if you look at the design of HMAC, so it considers key first, then message, then key. So prefix and suffix both components have been considered, and it is using both inner hash and outer hash, and the derivation of key along with padded zeros, key along with padded ones. So inner pad and outer pad both have been also considered. In other words, this HMAC, why HMAC is considered as one of the secure message authentication code, because it has considered the potential presence of threat in secret prefix, secret suffix. So it is avoiding those threats. At the same time, that key is also derived from original key along with padded zeros and padded ones, and it has used both inner hash and outer hash. With that, HMAC can avoid the existing threats by which adversary may try to forge message authentication code. Now it is up to the developer or application provider which primitive can be used for what security property. So for authentication using symmetric key, one can go by HMAC kind of message authentication code. For data integrity, one can go by SHA family, SHA-1, SHA-256, and so on. And for data confidentiality, one can use advanced encryption standard if block cipher is preferred, or one can use RC4 if stream cipher is preferred. Now, in summary, for achieving data security with respect to data confidentiality, data integrity, or data authentication, one can use symmetric key cryptographic primitives by which data security can be achieved. Next,